Hey friends, welcome. Today we are going to discuss system, assembly and ensembles. Now, under the heading of statistical thermodynamics, as we know that we are studying individual particles. So, according to classical thermodynamics, or you might have studied the definition of system. So, system, it is nothing but it is anything which is under observation and it is separated by a fixed or an imaginary boundary. So similarly, the definition of system under statistical thermodynamics, it will be if we are having several number of particles, then individual particle is known as system. So suppose if I am considering oxygen gas, then individual oxygen molecules will be considered as system, because under statistical thermodynamics we are studying individual particles. So I can write any single particle, it is known as, or it will be our system, because under statistical thermodynamics we are studying individual particles. Okay, now assembly means the collection of particles as a whole is known as assembly. So these individual particles, when they come together, then they form assembly. So as we know that when different peoples they come together, or when different people they come together, then it forms assembly. So one of the best example is like we have Lok Sabha and Rajya Sabha, wherein the elected members throughout the country they go and they represent their areas as well as their states. So it is nothing but it is assembly. So when individual particles they combine together, they form assembly. And ensemble, it is nothing but it is the collection of very large number of assemblies. So these assemblies, when they combine together, then they form assembles, and which are independent of each other, but they have been made macroscopically equal. So assemblies or assembly which are independent of each other, they will combine together and then they will form ensembles. So individual particles that we are studying is our system. Then those individual particles, they will come together to form an assembly, and those assemblies having, or those independent assemblies which are made macroscopically equal to each other, when they combine, they form ensembles. And these ensembles, they are further classified into three categories, or three important categories that we are going to see. The first is macrocanonical ensemble. Macrocanonical, then we have canonical, and then we have grand canonical ensemble. So before starting the ensembles, I will just want to throw on light on that when we were studying system, then we were studying open system, closed system and isolated system. So our ensembles are also similar to those systems. Like a macrocanonical system, it is similar to our isolated system. Then canonical, it is similar to our closed system, and grand canonical is similar to our open system. Now how it is that we will study. Now macrocanonical ensemble, they are made up of large number of individual assemblies having same energy, same volume and same number of system. And these individual assemblies, they are separated by rigid and insulated wall. So as they are separated by rigid and insulated wall, that means that no energy, no volume as well as no number of particles can transfer, or they cannot move, and hence it is similar to an isolated system. If I want to show an macrocanonical ensemble by the diagrammatic representation, I can show it in this particular form. Okay, we have different assemblies having different energies. Like we have EVN, I'm drawing a bigger one. So and they are separated by rigid isolated walls. So if they are separated by rigid isolated walls, then energy cannot transfer as well as mass cannot transfer. So once energy and mass they are not able to transfer, it is similar to our isolated system. So macrocanonical ensemble, it is nothing but it contains assemblies having same energy, volume and number of particles, and all these assemblies they are separated by rigid and isolated walls or rigid and insulated walls, and hence no exchange of energy as well as number of molecules or energy as well as mass will take place, and hence it is similar to our isolated system. Moving on to the canonical ensemble. Now canonical ensembles, they are again collection of large number of assemblies which are having same temperature, same volume and identical number of particles. Okay, so canonical ensembles are systems, they are made up of large number of molecules having same temperature or large number of assemblies having same temperature, same volume and same number of or identical number of systems, and all the assemblies as the assemblies possess same temperature, it means that all the assemblies are in thermal contact with each other. That means all the assemblies they are touching each other via so I can draw it in this way. So all the assemblies they are touching or they are in thermal contact with each other, so they will have TV, and so they are in thermal contact with each other, and hence the energy transfer or the temperature transfer can take place, but the number of molecules in the individual assemblies they remain same. So it is like our closed system, as in closed system we can exchange energy but matter cannot be exchanged. So over here also in case of canonical ensembles, the energy or we can say the exchange of temperature will take place or there will be a thermal equilibrium in the system, but the number of particles or the number of molecules in each assembly it will remain same. And our third type of ensemble, that is canonical ensemble. In canonical ensemble it is made up of large number of individual assemblies having same temperature, same volume and same chemical potential mu, and these ensembles they are made up or these ensembles they are separated by permeable walls. So if they are separated by permeable walls, then in case of permeable walls the particles they can exchange or TV mu. So as they are separated by the permeable walls, then the particle or the individual atoms as well as molecule can easily move through all the assemblies, and hence there is an exchange of temperature as well as there is an exchange of number of molecules. But as we know that as the systems are always under equilibrium, the chemical potential of the system always remains constant. So although the number of molecules will not or will the particles will move throughout the system or it will move throughout the ensemble, but the chemical potential mu will remain same, volume of the individual ensembles will remain same and the temperature will remain same. So this grand canonical ensemble it is similar to our open system, wherein the exchange of matter as well as exchange of energy will take place. So as over here, as temperature also changes as well as number of molecules or the individual particles and molecules they are free to move anywhere, and hence it is similar to our open system. So as again once we will revise what is system. So system, any individual particles which are under consideration is known as system. Then all those particles when they come together they forms assembly, and individual assemblies when they come together they gives us assemble, and this assemble they are further classified into macrocanonical ensemble, canonical ensemble and grand canonical ensemble. Hope the topics are clear. Thank you very much.